Hello, my name is Bernard Adderhold. Today I'll be framing out a machine learning project designed to solve a critical issue in the cybersecurity industry, analyst burnout caused by data overload. The problem is that security analysts are drowning in a sea of low quality alerts, leading to fatigue and increasing the risk that a real threat gets missed. This is an attractive opportunity for an ML solution because it meets three key criteria. First, there's a clear problem with a significant business cost. Second, machine learning is a perfectly suited to automate the pattern recognition work needed to find the real threats. And third, security leaders and business executives deeply care about solving this to improve efficiency and reduce risk. Following the crisp DM process, we can frame this project clearly. Our target audience or user is the Tier 1 security analyst. The problem is their inability to effectively triage high volume alerts. Success means improving the threat detection speed and reducing analyst fatigue. For metrics, our key outcome metrics would be reducing the mean time to respond for critical alerts. Our model's output metric would be its F1 score in classifying alerts as critical or benign. The factors we'd use to predict this include things like IP reputation, file hashes, and historical alert data. My solution concept is an intelligent alert triage assistant that scores and prioritizes alerts in real time. To validate this before heavy investment, I'd use a three-step iterative plan. First, I created mock-up to confirm with analysts that the workflow solves their problem. Second, I build a simple rule-based historic to establish a performance baseline. Finally, I train a simple ML model and prove that it provides a significant performance boost over that of the baseline. For the system design, I've made three key decisions. First, this must be a cloud-based system, as security data is centralized and requires massive computational power. Second, the model will use offline learning, meaning it will be retrained on a regular schedule, like daily or weekly, which is sufficient to adapt to the evolving threat landscape. And third, it will provide online predictions because analysts need an immediate real-time priority score the moment a new alert arrives. Finally, we must consider the risk. In production, I anticipate three main issues. First, data drift, where normal network behavior changes over time, making our model less accurate. Second, concept drift, where attackers develop entirely new techniques that our model has never seen. And third, adversarial attacks, where attackers could specifically design threats to look like normal traffic to evade the model. A robust monitoring and retraining plan is essential to mitigate these risks over the model's lifecycle. By following this structured approach, we can effectively frame, validate, and design an ML solution that addresses a critical need in cybersecurity. Thank you.